Hello everyone, this is Dr. N.G. Praveena working as Associate Professor in the Department of ECE at R.M.K College of Engineering and Technology. In this video, I am going to discuss about the concepts of linear predictive coding. What is meant by a linear predictive coding? It is nothing but a model based source coding technique which is used for the speech signals. It operates at a lower bit rate of 1.2 to 2.4 kilobits per second. This technique is known as linear predictive coding, which depends on the parameters of the speech signal. Here, normally the speech sounds are categorized as voiced and unvoiced. When voiced sounds, speech signals will produce when the vocal cords vibrate, when human being speaks, when any animal or bird or whatever it is, it's going to speak. When this vocal cord vibrates, right, by the voiced speech will be produced. So, when the voice cord will be tensed or when it will play no role, say for example, if you speak vowels A, E, I, O, U, the voice cords will be tensed, it will be compressed. When you sound some alphabets like S, C or F or etc. or going to speak by a human being, the vocal cord will not be tensed, it will be a light one. This gives about the linear predictive coding speech synthesizer. It is used for encoding of speech. The process is explained here. Initially, the speech signal is observed and it should be classified either as voiced or unvoiced. When it is voiced, the corresponding pitch frequency has to be determined. The corresponding pitch frequency has to be determined for the voiced signal. The filter coefficients and the gain G are determined. The filter coefficients and gain G are determined. And finally, they are encoded in the sequence of binary digits and finally they are transmitted to the receiver. The voiced or unvoiced information bit activates the voiced or unvoiced switch. Either it will activate the voiced or unvoiced switch, which consists either of the impulse generator or noise generator to the prediction filter. This is your LPC model for the speech signal. Here the word hi, how are you? Look at this impulse. That impulse has been categorized as H hyphen AI, H hyphen, look at this one, H hyphen AU, hi, how are you has been splitted, are you has been splitted. So, you are for any voice signal that has been transmitted, either it should be voiced or it should be unvoiced. It is amplified by an amplifier. Finally, it is given to an LPC filter. Finally, the speech is synthesized. This is a LPC model which is used for the prediction of the speech signal. LPC encoder block diagram and decoder block diagram has been represented here. LPC encoder block diagram. This is your transmitter. I am writing this as X of K. This is my speech signal. The speech synthesizer analyzer, and I have a speech synthesizer block and encoder block. The speech analyzer is a signal processing block which processes block by block of 10 to 30 milliseconds long. the parameters like the prediction error filter coefficients, voiced or unvoiced parameter, and the pitch period or the output, the output of the analyzer. It will give you the complete description of the signal under consideration. These parameters are fed to the encoder for the onward transmission to the receiver, and also it is fed to the synthesizer for locally generating the estimate of the speech that the receiver would synthesize. The error between the actual speech input, that is x of k, and the locally synthesized speech xq of k cap is fed to the encoder for the onward transmission of the receiver. So here ek, I can write on this as xk minus xq of k, the whole cap. The Lpc decoder has been explained here. The Lpc signal which is transmitted has been received here. It is applied to a decoder block. From this, the synthesizer block has been used. It is going to synthesize the speech signal. The received Lpc signal is applied to the decoder, which decodes the parameter values, and then it is processed to the speech synthesizer block. The synthesizer block produces a synthesized sequence that is represented by x cap of n. The output of the synthesizer block is added to the error signal E of n, which gives you xq of k, that is nothing but eq of k plus x cap of n. The analog speech signal is applied finally to a low pass filter. It is given to a low pass filter. The low pass filter reconstructs the sequences and performs the function of interpolating the signal between the sample points. The advantages of Lpc is it has low encoded data rate and the bit allocation depends on the specific characteristics of the signal. Whereas disadvantages is the parameters are evaluated only for small segments of 10 to 30 milliseconds long. For this, it is going to be processed, and the signal which is synthesized, it will sound monotonous, it will sound in the same fashion. That is the one more disadvantage we have in Lpc. Thank you all.